Um, what we're going to talk about today is WCF data services. Before we go into WCF data services, I'm going to give you guys a little bit of background on OData in general. I'm sure most of you are aware of RSS protocol. So at some point, Atom protocol was also published, which was supposed to serve as a replacement to RSS, improving upon RSS protocol, which essentially is suitable for consuming data over the internet. It has a couple of shortcomings that were further overcome when Atom Pub protocol was released, and just like name implies, Atom Pub provides publishing capabilities or writing capabilities on top of Atom. And OData builds on top of both of those protocols, allowing you to consume the data, publish the data, but it also provided a number of important extensions on top of Atom Pub, such as extensive querying abilities. The idea behind OData is to allow any client to consume the data over the internet using a RESTful way of communicating with whatever service provides the data. So at its heart, OData has a very deep commitment to REST, or representational state transfer, which is not really a technology, but a way of writing web apps when URIs map to certain resources over the internet. In case of OData, those resources are essentially data, whether queries or individual entries. And OData allows you to structurally expose those entities as types over HTTP. And that's really what OData is all about. It is, of course, standard-based. Microsoft pioneered OData protocol, but it has submitted it to standards body. And currently, they have released version 3. That was earlier this year, if I remember right. As a result, you have some assurances that if you buy into technology, you're not going to be abandoned, because it's not just Microsoft proprietary technology. It's an open standard supported technology, which is really, really important. As I mentioned before, it allows you not only query, which is most of the internet allows you to do, but also publish some data using specific formats. Now let's talk about WCF data services. So at a high level, WCF data services is simply Microsoft implementation of OData protocol. That one currently in version 5.3, and it is available via NuGet. So if you want to create a service, all you have to do is pull the NuGet packages. You can search for OData, and a few of them will come up. And you'll need a client and a server one. If you want to write just a service, then you need a server-side package. But essentially, that's how easy it is to get started with OData. Now, before we jump into demos, I'll always like to talk about return on investment, or ROI, really of any technology you pick up. In other words, personally, I always like to know that in exchange for my time, possibly money, but not in this case, in my time commitment, what am I going to get back? Is this technology going to help me? Is it going to save me time and effort? And that's really what, in my opinion, WCF data services provide. It gives you pretty big return on investment because it allows you to quite easily expose your entire database over the internet. A couple of important points to notice. Really two words that are part of the name. One is WCF, and just like the name implies, WCF data services is at its heart WCF implementation. And you will see how that comes into play in just a few minutes. And of course, WCF data services is all about data. And just like AtomPub allows you to do and OData protocol specifies, you can publish and consume queries. And we'll see some of those examples as well. One important part, because it's a web-based technology, you can consume it from anywhere. Regardless, Microsoft did write clients for all the key platforms. So there is a client library for Silverlight, for full.NET, for WinRT or Windows Store apps. And of course, even there is a JavaScript, OData JavaScript library that simplifies a little bit the way you communicate with an OData endpoint from JavaScript. In other words, if you expose the service, anybody can consume it. Because it is WCF, you're not leaving your data totally exposed and unsecured over the internet. You can simply use built-in feature of ASP.NET and WCF to secure your service, to make sure that unauthorized users aren't going to start consuming your data. And of course, it's supported technology. So if you have a problem, you can call Microsoft support and ask for some help. To build a service, you really don't need much. So I'm going to start with a database, which is really your typical flow into WCF data services. You typically already have data somewhere. So now your next step is to provide a data source to WCF data service. In my demo, I'm going to use Entity Framework, Code First more specifically, or DB Context API, but you're not limited to that. What WCF data services wants is really some kind of data source that exposes data sets via iQueryable interface. And it can work with whatever you have available. You can technically even write your own provider if you want to. Of course, the ROI kind of drastically diminishes because you have to spend a ton of time. So we're not going to go that route. Instead, we're going to start with an existing database. So now we're going to spend most of the remainder of the time in demos. So what I have here is a plain project. The only thing that it has in it is references to OData libraries. And those are starting with Microsoft.data.whatever. And those are OData libraries. And of course, I need Entity Framework reference because that's what I'm going to use. So now, we're just simply going to build WCF data service from scratch and explore all the key features that the service provides. So first step, obviously, is to create the data source. And to do that, I need to add entity data model. I'm going to standard add item window, find ADO.NET entity data model, and give it a name, Chinook model. The reason I want to mention that is because this demo is using Chinook database, which is available on CodePlex. It's sort of like a much simpler than something like AdventureWorks. So it's a lot easier to download and get started with. My demos, if you download them, they don't include the database, but you can go to CodePlex and just download the script, run the script, and it'll create that database with data for you, so you can run all the demos. I'm going to create a model. I'm going to generate it from database, create new connection, pick the database, click OK. And I'm going to select all tables. Once that process completes, I will have a working EDM model or entity framework model created for me that maps to my database. If you want to see what's under the cover, you can open the context file, and you will see that it inherits from DB context. The reason this happened is because I'm using Studio 2012, and defaults for entity frameworks have changed since 2010. It used to be that default would be Object Context API, But Microsoft now recommends that you would use DB Context API when working with Entity Framework. And you used to have to jump through some hoops if you wanted to use like code first with WCF data services. It's not the case anymore. So I'm going to use DB Context API. Now that my data is created, all I have to do is now create the actual service. Again, I'm going to go through new item, pick a WCF data service item template. Again, just change the name right quick to keep it consistent. And just click Add. What's going to happen now, my item got added. As you can see, it inherits from data service, which is generic class. And very so helpfully, there is even a comment here of what's supposed to go into your generic parameter. And what's supposed to be there is our DB context class, or Chinook entities. You also have some samples for configuration. I'm going to start with one. Again, it goes back to the fact that even though Microsoft is using conventions quite extensively, they don't want to leave you fighting those conventions. As a result, you have to make sure you secure your data. And you can secure it via configuration that is exposed to you in the initialized service overridable method. So in my case, I'm going to use a star, meaning I'm going to expose all the tables. Of course, you don't have to do that, and typically you wouldn't. And if you want to know what set name is, all you have to do is open your model, and you will see all the names. In my case, I can use something like artist. I know I have that set in my model. And then all I want to do is browse to my endpoint, which is my SVC file. And if you don't provide anything else on the URI, you will get an informational page that is built dynamically. And then what it will list is all the entities that your service exposes. So as you can see, there is only one set here. I can change it to star, compile that, and refresh my page. And now I see all the entities exposed by your service. Of course, if you want to give somebody endpoint like that, it's not really enough information for them to work off of. So there is a whole number of parameters that you can pass to WCF data service. One of them is $metadata, which gives you much more extensive help page. We'll list all the entities, but it'll also list all their scalar properties as well as navigational properties. So you can, at this point, work with your service. I'm going to copy this endpoint, switch to Fiddler for a minute, and let's explore the service. To query a specific set, all I have to do is add the set name, make sure I add the set name to my endpoint. And if we take a look at the result, you will see that the list of artists, which is my result set, got returned. It is returned in JSON format, and that's the reason for that is I specify accept header. So if I take that out for a minute and execute it again, now the XML, which is the default, is returned, which is a little bit more verbose. And if we look at the entry, you have to kind of dig really deep to find the actual data. And this is more what AtomPub is all about. So this XML result set is more like what AtomPub will expose to you. So let's switch back to JSON for a minute. And this specific format is called JSON Lite. So it has a lot less metadata than full-blown JSON. And to do that, I have to add OData equal verbose to exact same accept header. And now you'll see I'll get a lot more information, still in JSON format, Still a lot less verbose than XML, but it does provide some metadata. For example, it gives me a way to navigate to each entity. So I queried all entities. If I want to look at one, it gives me a URL. And of course, there is a data, and there is actually navigation properties. Those are not loaded by default. So let's flip back, switch to OData. OData has a number of operators that you could use as well. So what we saw right now is all the data that I'm trying to get from the artist set. However, that's really not very likely that you would need to do just that from your application. So as a result, you can use a whole bunch of operators here. One of them is filter, which is essentially a where clause, and you use the standard URI encoded syntax. So if you have spaces somewhere, then you have to URI encode whatever it is you're trying to do. So in my case, I can do something simple, artist ID greater than 10. Of course, that's not going to work all that well, because that's not URI encoded string. The reason I wanted it to air out is because I wanted to show you a couple of things you can use to troubleshoot errors, which sooner or later does come up, and you need to know how to do it. So first step, you can enable verbose errors in WCF. So instead of giving you something cryptic like an error occurred, it might actually give you a full stack trace if it's appropriate. Another thing you can do is override handle exception, and in here you can implement your own custom login. So there are a couple of ways you can handle exceptions in your service, and these are your primary ways to deal with errors that will inevitably come up. So if I take a look to see what my error was before, it's just your standard web page that an error occurred. Now if I build it again and fire exact same query, I should get something more descriptive. Not in this case, but in some cases you will get something more descriptive. This was intercepted way before this code got into WCF because my URI was incorrect. But I could have correct URI, but still maybe ask for invalid data, and then you will see a stack trace. So let's fix that problem. I simply am going to URL encode, and I use the GT, LT, all those standard operators are supported by OData. The easiest way to find out what they are is go to odata.org, and you will find a whole lot of information about standards. Part of it will include all the operators, anything that starts with $, as well as comparisons such as GT or LT or any other ones. Okay, I mistyped something here, but I mistyped the artists in here. So let's fix that. Add the question mark for my query parameters. And now all I get is artists that start with number 11. So my where clause, of course, got processed properly. So in addition to where clause, you can use any number of operators. We looked at $filter. There is $order by. So by default, I got my artist queried by artist ID. I can switch to name, and now they're sorted by name. What I'm trying to show you here is the fact that you don't have to use any specific client. You can literally pull up Fiddler or use jQuery, Ajax call, or whatever else you want to do. Get the data in JSON format and just serialize it straight in your web page. So you don't really have to jump through a whole bunch of hoops, because OData is all about exposing stuff over HTTP, hence your URI will work just fine. Of course, not often that you need to return the entire entity. So what if you want to simply return a subset of fields? You can easily do that using a select operator, and I can say, I only want to select a name. and again, just the name got selected. What about if you don't want a whole set? What if you want to retrieve just single entity? In that case, your format would be to supply primary key in parentheses. So now I'm going to retrieve an artist with ID 01, and I get ID name, and you always get this metadata tag that is part of JSON Lite protocol, or format, more exactly. Now, we have relationships. Again, OData supports a way for you to navigate all the relationships, but it also supports to return the data from related tables in single query. Let's use the expand operator. Expand equal albums, I think, is the correct navigation property. And now what I'm getting, not only the artist data, but all the albums that are related to. Why this is important is sometimes you can save yourself a round trip from your client by including the related data if you want to show it right away. So you can use sort of a lazy loading. If you switch to verbose format, it'll actually give you URIs to navigate to related data sets. Or if you know it, you can just use the expand operator and go ahead and include all that in a single query. More importantly, you have to page your data. So let's do a little test. One thing you can do, and probably should do, is protect your service. So let's set max result set for collection to 10. What that does is limits the service from returning 10 rows at a time in my example. You can set to whatever page size you want. One important thing to notice, this does not protect the client. It protects the service. In other words, client will actually, if they ask for more than 10 rows, they'll get an exception. Hopefully something descriptive that tells them what went wrong. So if I compile this and just ask for all artists here, I will get some data, but you can see JSON parser inside Fiddler can't parse it any longer. And the reason for that is this. So it adds the actual exception text to the end of result set saying you asked for too much data. So it doesn't bother to provide accurate representation of 10 rows. The reason is we want to let the client know they asked for something incorrectly. Now, how do we fix that problem? How do we ask for a specific result set? There are operators, top and skip, that you can use to limit your result set and essentially provide paging. So in this case, I want to page 5 rows at a time, and I'm on page 3. And this is what happens. So we start with ID of 11. So this is how easy it is for you to implement paging in WCF data service. We'll also see how you can do the exact same thing from a client. And this pretty much concludes the basic operators that are available to you. Question?
So the get, post, and puts, those methods, implementations kind of behind the scenes after this call to initialize service?
The question is, what about the verbs? I guess get and put verbs. WCF data service makes certain assumptions. So if you query the data, it assumes you want to use the get verb, which is what Fiddler does. If you want to post some data, you can use any of the other verbs like delete or patch or put, and it'll automatically map it to the correct operation for you. It's using that type of convention, saying, okay, if you issue in the put, I'm going to translate that to insert. I'm going to get the data you're posting and shove it into the appropriate entity. And we'll see that hopefully in just a couple of minutes. It'll make a little bit more sense. What we want to talk about next is customization. So far what we've seen is everything out of the box. It's highly unlikely that you always want to return full entity set or only use the entity types that are mapped to tables. Oftentimes you want to build like a query screen that only selects a subset of columns. All that is for efficiency purposes. So let's customize it. And to customize WCF data service, we need to start by customizing the entity framework model. We can do that by switching to model browser. And at this point, all I want to do in my simplistic use case, I want to return a summary of artists from the artist table. I want to summarize them by maybe first letter of the name, and I want to retrieve number of artists for each letter. So we're trying to build this simple Rolodex type of app that people can click on letter and see the entities that start with that letter. And that's what we're going to build. First thing we want to do, I want to create a type that will be used for my result set. What I'm going to do is create a type. I'm going to give it a name, artist, alphabet, info. Just something semi-descriptive. Now the type is created. Now I need to add some properties to that type. I'm going to add a scalar property, which is going to be a string, which is going to be a letter of the alphabet. And I want to know how many artists belong to this letter. So I'm going to create another property called total. So now I created what's called a complex type, meaning a type in entity framework terms that does not map one-to-one to a table, or does not map one-to-one to an entity that maps to a table. If I close this and look at my generated code, you'll see that whenever I save my diagram, the code generation kicked in, and now I have my class auto-generated. And that's the important part. So if you try to manually add a type, it might be overwritten when you do code generation. So you don't want to manually edit the type that entity framework generates. Now I'm going to jump to my service, and what I'm going to do is create a service operation. And service operation is an important concept of WCF data services that allow you to customize two things. One, you can customize a result set, so you can retrieve a custom query result, or you can customize what essentially would map to a void function. In other words, I'm going to call some method on the service, have it perform some database operation, and just tell me when it's done. And if not, return an exception if something went wrong. Those are two types of customizations you can use. And if you build in an app on top of WCF data services, it's nearly 100% guarantee you'll have to do it at some point. So let's build the query one first. First thing we want to do is use the attribute. That's how WCF data service knows I'm adding a new operation to it. It's going to be a public method, and I'm going to return IEnumerable of artist alphabet info, and I'm going to call it artist summary. And this is just essentially a name. Now all I need to do is create a result set. What I'm going to start with is to create a query. And what I'm using is simply plain link query. And now WCF data service comes in, and because I inherited from WCF data service and gave it a type, that exact same type, which is my DB context, is returned to me in property called current data source. From any operation, as a result, you can have access to your entire entity framework model, including those tables that you're not even exposed in WCF data service. Full customization. And I'm going to return the data from artist, and I'm going to reshape it. So I'm going to group it, in this case, group name, and I'm going to simply just grab the first letter of the name and group it into letter group. And letter group, of course, is just the name of a group. And now I can select that data. And I'm going to select anonymous type. with two properties. Letter would be a letter group.key. Key group one artist by, let's see, that's better. So I'm grouping artists by the letter, and I'm selecting the total for each one, and this is going to be my count in this case. So now I got the data working. However, if I would just try to return this, I will get an exception. So there are some workarounds you have to go through. They're not really all that complicated, but because WCF Data Services has to map to exact types, there are a couple of hoops you have to jump through, and those are minor. One, you have to return anonymous type right away. Delayed query execution will result in exception. And now, after you do that, I can reshape my data into the final result set. And I'm going to return alphabet info here. And I'm going to populate properties from my intermediate result set, which is my anonymous type. And now everything should work just fine. Let's see if that's the case. I'm going to copy my method name, go back to Fiddler, fire that, got an exception, artist summary. And there is one thing I forgot to do, which is set up rules for my service operations. You have exact same type of authorization rules for entities as you do for custom operations. In my case, I didn't set up a rule for my artist summary, and I can set up rules operation by operation, or in my case, I'm going to just use wildcard to set up rules for all operations. It's really just kind of to save time. And if we look at the result set now, I have my summary information now returned to me in a query. So this is how we do custom query. So how about batch updates? There is another attribute for batch updates, and it's all familiar one, web invoke. You could have used it in other projects, in WCF, for example. This one is just going to be void, and this is going to be a pretty contrived example. I'm going to call it update artist, which typically I wouldn't do, but it demonstrates a couple of points. What I'm trying to do here is simply create custom operation that just performs batch update. In my case, just simply updates a single row. To get data, again, we use current data source. And you're going to find yourself using that data source in pretty much every operation. That's how you have access to data. Then I'm going to update the name, new name. And the last thing I want to do, and now we're entity framework world, is submit my changes to the database by fire and save changes. And that's really how easy it is to perform batch updates. I'm going to build that. No guarantees this will work, and that's just a direct result of coding in front of audience. Things usually don't work, but we're going to give it a try anyway. We have artist ID, and we have one more parameter, new name, and we're going to call it some name, something. Now. So now, let's make sure we have our data here. One thing I have to do is switch to post operation. So all web invoke, they map to post operation. So this return essentially nothing because my type was void. And if I refresh my data, you will see that the data got updated successfully. So what we talked about here is ability to customize built-in service with what essentially is an extension. Either a query, custom query, using custom types, or custom batch updates with whatever parameters you want to pass in. As I mentioned before, there is really almost no way around it. However, one thing I'm going to mention, if you find yourself writing operation after operation after operation, that's probably a sign that your WCF data service is not really the right fit. If all you want to do is customize all of your entities, you might as well just write plain vanilla WCF service or use Web API. Your ROI becomes kind of low at that point. But if mostly what you're trying to do is expose entities for basic CRUD operations and provide just some level of customization, that's a really pretty fast way of doing it. Now the next area for you to customize is interceptors. And interceptors come in two flavors. You have a change and a query interceptor. And just as name applies, those are routines that will fire as part of a query. Essentially navigate to an entity set and you query it. That would be your query interceptor. Or if you issue an update, that would be your change interceptor that would fire. Let's write one. That particular attribute takes one parameter, and the parameter is the name of the entity set you're introducing query interceptor on top of. And you have to follow a specific signature. It's expression of function of whatever entity type is, which in my case artist, and Boolean, which is the result value. I'm going to import all the namespaces here. And just to follow some kind of a naming convention, we're going to call it onQuery artists. It takes no parameters. The reason for that is that you know what set was queried out. So if I build this, let's return something fast. I'm going to just return true, which essentially not going to add another where clause on top of my data. I flip back to my fiddler, switch to get, switch to artists. I got all my data back, except I didn't ask for a subset. So let me just delete that out so I don't have to keep on adding top clause everywhere. So let's query this data. I got all my artists. Now, why would you want to use this interceptor? It's a really twofold approach for you. One, you can simply customize the query. An example would be http context.current.request.queryString. You can do something like this. Partial name. And in here you can say artist.name.starts with name. Something like this. In other words, you can inject custom query parameters through the query string and then process them through query interceptor. One thing that we'll also notice that HTTP context is available to you. So another role change interceptor can play is something like this. Whoops. HTTP context.current.user.identity is authenticated. So you can use that to segregate your data between unauthenticated and authenticated user. Maybe unauthenticated user can get some subset of your data that makes sense. authenticated can get all the data from. So you can easily inject authorization rules as well as custom query capabilities through query interceptor. So if we're going to go do this, we can say return true. Otherwise, well, not like this. Still needs to be a lambda expression. Otherwise, we can return false. So this is a basic way you can implement authorization in those methods. So if we query this data here, because I'm running in Visual Studio Web Server, it's using Windows Auth, so that's why it thinks I'm authenticated. If I want to simulate this in another way, forms identity, something like this. Build this. Now, if I'm authenticated through forms, I will get some data. Otherwise, I will get nothing back. And as you can see, my results are no. So while we're on the topic of identity, one thing to notice is that security is a very important aspect of WCF data services. Because it inherits from WCF, securing your service with something like forms authentication is really as simple as changing the config file. And because I can never remember all the stuff that needs to go in config file, here's an example. I'm switching authentication to forms. I'm denying anonymous users any access to my service. And then I'm exposing one endpoint, which is part of ASP.NET authentication service. I allow unauthenticated users to this one. And then what I do, I simply write a membership provider. In my case, I only overrode one method, validate user. And I'm inheriting from default membership provider. So as you can see, I wrote like 3 lines of code. All Authenticate does is open up connection and make sure that the user credentials are correct. And all I have to do is inject this specific provider. I'm going to clear all the default providers out of my web service. And then I'm going to inject my custom provider. So if I were to navigate to this endpoint, let's try this. View in browser. Localhost. You already see that it redirects me to a login data. It already denied access to my service because I haven't authenticated before. And we'll see when we look at the WinRT app how you can easily implement that in a client via, in this case, via cookies. Now that we talked about authentication, this is kind of a trivial example. And since I'm going to use artist in just a minute, I'm going to simply return true for a sec. And now what I want to talk about is change interceptor. Again, it's all attribute driven behavior. The same virtually thing you have to do, you have to provide an entity set for your change interceptor. This one has to follow a specific signature as well. On change artist is just a name. Name is irrelevant, but parameters are relevant, and they have to follow this specific syntax. Change interceptor accepts 2 things: the entity that is being updated and the operation that is executed on that specific entity. And if you look at the operations, your basic CRUD operations are there: insert, update, and delete. And at this point, you can write a custom code here. Again, you can enforce authorization here, or you can do something different. So you can say, for example, say if you want to always track who made the change. You can do it as simple as, well, this is name, But say you have less modified by property in there, and you can do something like this. You don't have to fire save changes. In this case, save changes is handled by WCF data services. So how do we call this in Fiddler, for example? So we can find a specific artist, and the reason I do that so I can get the right properties out. I have two properties, I'll just copy them. Then I'm going to switch verbs, in my case to patch, to issue an update. My request body is going to be my entity. So it's an artist entity with two properties. And then I need to set the content type on here. And the content type is what tells WCF data service how to parse the payload. In my case, it's a JSON payload. I need to tell it that I'm passing content type application JSON. Let's query this, fire this method. Artist 403, I got unauthorized here. Yeah, that should have worked. Let's see if my composure is all correct. Except header, I really don't need mistyped content type here. Let's try it again. Patch type. Make sure I'm on the right method. Yeah, it should be on the right one. But I got forbidden in there, so I don't have rights to perform this operation. This is really how it should have worked. We'll see exact same thing I can do from a client. I will spend a ton of time on doing it in Fiddler. Oh yeah, actually, I remember. It's no, that should have worked. What did you say?
Your access is set to read only.
Where?
All read.
No, it should be all because no, all read. Thank you. Never changed it. Because it's a change interceptor, it's not a custom operation, it's using the entity set rules in this case. Let's try it one more time. Got another error. Content type, I thought I put that one in. Application JSON. Oh, colon. Yep. There we go. Let's see if that'll work. That'll work. So one application for you to use change interceptor is, stamp the data with the user who's logged in. Another one, like I said, is enforce authorization or authentication rules. So it's really entirely up to you what you want to use change interceptors for. Now, I think that's really all there is to Fiddler. So what I want to do is switch to a WinRT app and see how easy it is to consume WCF service from WinRT. So this app already has a reference. I'm going to just delete it for a minute. Delete that service reference. So I'm building WinRT app. I can easily just add the service reference to it. And the same experience you're going to see in most Microsoft technology stacks, UI stacks, except, of course, JavaScript. So if I'm going to add a service reference, it finds my service that is part of the same solution. Of course, you can also point it to URI if you're not hosting a service, somebody else does. And what Microsoft tooling is going to do is generate a proxy. And the main class in there is the proxy to my entity framework data DB context. And it'll have exact same properties as my DB context does. Data service context is essentially a client-side class. But if you look at the properties that got built out, you'll see I have my customers, employees. Where is artists? Somewhere in here. So there is artist table. In other words, it has all the properties built into the proxy that I can use to directly query the data. So if I run this after adding a service, so now the first thing this specific app does, it builds the Rolodex of alphabet information. And then if we drill down into any of them, we'll see details or listing of artists. And in this app, I have some basic editing capabilities, so I can change the name, for example, and fire save command. And let me just close this off, flip back to desktop, stop this. Let's see if that part worked again. But let's look at the code. So we've seen what I have to do in Fiddler. What do I need to do in client app, which is using some sort of a build proxy? One thing I was going to mention is that the proxies that is generated is using a begin-end pattern, using async result, which is okay, but if you're writing something like WinRT app or you're writing a .NET app that is using .NET 4.5, which has async keyword in there, you can quite easily convert those methods to task-based API. So let's take a look first off into login information. And that's something you would need to do if you're trying to authenticate a client. That's not, since we're using default membership provider, I wrote like a little extension method that's using HTTP client to log in. It's using your basic, well-documented membership provider API. It logs in, and the only thing that it does at the end, it captures the return cookie. So the cookie is something that provides authentication mechanism to ASP.NET, which is under the cover of my WCF data service. What do I do with that cookie is very, very simple. Whenever I issue any kind of request through my proxy, I can subscribe to on-sending request event, which fires before a request sent to the server. And when I do that, all I need to do is inject a cookie into my request. And at that point, I can continuously use the same authentication mechanism on subsequent requests. And this is a basic way you would write the code if you want to secure your service with forms authentication. If you're writing a client that consumes the data across the internet, and that's probably the best route to go. Although you can use Windows Auth if you're hosting on the internet, for example, and you want to simply rely on Windows Auth. At that point, you can cast current user to Windows principal and interrogate that for Windows information. You can do that in your operations or your interceptors. Either way, you can enforce Windows security just as easily as you can enforce forms authentication. Whenever we retrieve custom data set, which in my case is basic alphabet information, that one is not exposed via query. And that's because it's a custom operation. So I have to invoke that operation myself. But to invoke it is really quite simple. In my case, I'm using HTTP client, and that's one thing I wanted to demonstrate is the fact that you don't have to use a proxy to communicate to WCF service. It's as simple as building a URL and executing the GET. In my case, because it's a WinRT HTTP client, it has getString async method that downloads that string, and all I'm doing after that is using JSON serializer to convert JSON to my list of objects that I'm passing in here. So as you can see, with maybe like 10 lines of code, you can write a number of extension methods on your context, where querying custom operation becomes one-liner. So you can cut down significantly amount of code you write on the client if you implement some common patterns, like a login or invoking a custom operation. When it comes to built-in entities, that code is much, much simpler. In this case, I'm trying to retrieve list of artists whose names start with whatever letter was selected from my app. In this case, I'm just using a link. All of a sudden, I'm out of this HTTP client, and I'm using strongly typed queries to communicate with my service. And that's really true power of using a pre-built-in proxy. It cuts down on the amount of code you have to write. And if I navigate to this artist, you will see that this property exists in my proxy. I didn't write any of that code. It was written for me when I added a service reference. Once I create data service query, which essentially is just a link query, but because it's a data service operation, I cast it to data service query, which is what this returns anyway. Whenever I fire link query on data service collection, on data service query, on data service collection, I get data service query type. Once I build my simple link, and let me break it a couple of lines so it's easier to see. I'm adding a where clause. I can just as easily add order by here. Again, it's a strongly typed link query, and my name is available. All that stuff was exposed through the proxy. And once I do that, I create a data service collection. I tie it to my context, and I'm loading the data by passing a query to data service collection here. And delete that out for a second. So a couple of things to notice here, which are really important, and that's how most clients, WCF data service clients, operate. They all have this concept of data service collection that you tie to the context, data service context. And that's really, really important to notice here. Because what this provides for me is automatic change tracking. In other words, I'm loading this list of artists. I can edit as many of them as I want, make whatever changes I want. I can add new ones. I can delete existing ones. All those changes are going to be tracked by my context. Excuse me. Not by their data service collection, but by the context. And so what happens at the end, all I have to do is fire save changes on my context, and this entire set of changes I just made are going to be submitted for me to the server as a batch. I have some ability to control the batch size, and again, in service, under configuration, I have the same setting there to control the batch size update. Now, if we look at the save code at that point, again, this is extension method, but the important part to notice is in here. I'm going to fire begin save changes method, and when it completes, it's going to give me async result, which I complete here, and then I have the results of my operation. And the only thing I need those results for is to check for errors. The other use case for those results could be if you have some data generated on the server and you want to incorporate those changes into your client-side data set. Again, I wrote an extension method that converts begin end pattern with async result to a task, and that was one-liner essentially. But what allows me to do again is write one-liner at that point to commit my changes. So once you write, like I did, 3 extension methods, a lot of code becomes really, really simple in your client. And as an added bonus, it's very, very little code that you have to write on top of getting a strongly typed result set. And that's something that proxy provides to you when you use Microsoft tooling to build it. Getting close to the end, so what I want to do is summarize a little bit what we talked about and leave a couple of minutes for questions. We talked about most everything here, so I'm going to leave my contact information here. If you have any questions, please don't hesitate to email to me. I will reply to every question. I will post the slides and the demo project, which is a WinRT project, on my blog as soon as possible. It should be there by the weekend. So what we talked about is WCF data services. It's a Microsoft implementation of OData, which is Open Data Protocol. It's following a lot of conventions to expose your data over what looks like RESTful API. It gives you an ability to directly query it using something as simple as HTTP client or jQuery Ajax. If you have a much smarter client like .NET, WinRT, Silverlight, you can build proxy that will cut down quite a bit on the amount of code. If not, you can use standard serialization practices and convert those entities to your objects as well. You're not locked into a corner with WCF data services. You can always break out of the built-in model, write your own operations that return data or fire batch updates. You can always secure your service, and you really should secure your service. Use any web security you want, Windows Auth, Digest, Forms Auth, which is what I use. Security is really, really important. As extension of security, you can provide various rights for your entity sets. You can make some of them read-only, some of them writable, some of them you can hide altogether, purely through configuration. And of course, you can further enforce authorization through change and query interceptors. Those are really the key concepts that if you can use those and get comfortable with them, as you can see, I wrote most of that code in front of you, so if I can do it, then I think anybody can do the same thing. So return on investment is really what I'm always beating on. So if you have 2 tables in a database, you can write WCF service in a day just as easily. If you have 1,000 tables in a database, there is no way you can come even close to what WCF data service gives you out of the box. So that's when your ROI is really big, and that's when WCF data services technology really shines. I think that's all I have. Any questions?